Now, let's discuss socket programming with TCP for the same example program. The difference is that in this case, the case of TCP, we need to build a connection between the server and client before sending any data. And that means we need to have a server that listens to and accepts client connections. Then we create the client code that contacts the server with the known IP address and port, similar to what UDP did. Then it asks to establish a TCP connection with the server. The TCP server creates a new socket other than the always listening socket it has and establishes the connection from the new socket to the client. This will let the server to talk to multiple clients at a time and not be blocked at its main socket with a single connection. TCP, as we discussed, provides reliable in-order byte-stream transfer between client and server. The flow of communication between client and server in our simple program with the TCP sockets would be a little bit different than our UDP programs. Similar to the UDP server, the TCP server should have a known IP and port for the clients to send requests to. Using these values, the server creates the TCP socket. Then, the server waits at the socket for incoming TCP connections. The client program creates its socket and contacts this known port on the server. But since TCP needs connection, the server is listening on this known port for client requests to connect and accept the connection. But it does not want to dedicate this port to a single client with binding it to the connection. So, it lets the client know a new connection port. The TCP connection from the client is made to this new connection socket, where the communication with the client happens. While the connection socket is closed after the communication with the client is finished, the server socket remains open while the server is running so that it can communicate with other clients that may want to connect and communicate with it. Let's take a look at the client side of our program for TCP socket communication. Many parts of the code, like importing the socket library and assigning a name and port number to the server, are similar to the UDP socket program that we previously discussed, and we will skip describing their details. Let's go to the first difference, which is in the creation of the client socket. Similar to the UDP port creation, AF-INET is used to say IPv4 will be used for addressing. However, we see SOCK_stream instead of SOCK_dgram, which means that connection-oriented byte stream will be used. That defines the socket as the TCP socket. The socket is next used for connecting to the TCP server and sending data read from the user input out of client socket to the other side of the connection to the server socket. Sending and receiving happens without involving the server name and address, as the byte stream is received from the connection that is from the known server. At the end, the socket is closed, which also closes the attached connection to the server. The server program using TCP socket programming also begins with importing socket library and defining the server port. Then, the server socket is created using IPv4 address family, AF_INET, and SOCK_stream that indicates this is a byte stream and therefore a TCP socket. The next line binds the server port to this socket. Server starts listening to this known port for incoming TCP connection requests from the clients. Within an infinite loop, incoming connections are accepted on the known server socket, and connections to the clients are created in a new connection socket. In this new connection socket, byte streams are received from and sent to the client without the need to add addresses due to the connection establishment. And the connection socket to the client is closed at the end of the communication with each client, while the listening on the server port to new incoming connections still continued.